right, we let f of x and y be equal to x over x squared plus y squared. And we want to find dy dx using implicit differentiation. And to do this, what do? We let f of x and y be x over x squared plus y squared. Full stop. And we proceed to say put f of x and y to be equal to 0. Just like that. To be equal to 0. Just like that. Thus, we have that x over x squared plus y squared is equal to 0. Like so. Right, with that said, if we have that x over x squared plus y squared equals 0, this implies that d dx of x divided by x squared plus y squared, the derivative of this, you can take the derivative both sides, like so. Okay, let's find the derivative of this. So the derivative of this of x, we use the quotient rule. The derivative of x is the number 1. And we have x squared plus y squared minus x into the derivative of that one is twice x. Is twice x, but we are adding something extra because we are using implicit differentiation. So the derivative of the x squared is 2x. The derivative of y squared is twice y. dy dx. Okay. We divide by x squared plus y squared. Like this. And you square these, and this result equals 0 because the derivative of 0 being a constant is identically 0. Right, when you get to this point, we cross multiply. And if we cross multiply and we distribute, we get x squared plus y squared minus 2x squared minus 2xy. We have dy dx equals 0. Just like so. Upon further examination of these, we look at these and we think very, very carefully, and you obtain the following. So that implies that we have x squared plus y squared minus twice x squared minus twice xy dy dx equals 0. X squared minus 2x squared is minus x squared. And this equals 2xy dy dx. Right. Divide both sides by 2xy. And we have y squared minus x squared. all divided by twice xy, like so. And this is dy dx. Okay, that is what we're getting. That is exactly what we're getting. Right, so hence, we're able to say that dy dx is exactly the same as y squared minus x squared divided by twice xy, like this. And this is the end of the solution. And this is the result using implicit differentiation. But now there are other things you need to focus on as well and look at other ways to, there's an alternative solution to this. So we look at the alternative. Alternative solution. What is the alternative solution? Right, the alternative solution is something we call the implicit. Something we call the implicit. Implicit function. Implicit function theorem. What is the implicit function theorem? And how to use it? Okay, shall see how that works. So f of x and y, we know very well that in this question, it's x out of x squared plus y squared, like this. And upon further examination, this actually produces f sub x, which is the partial derivative of f with respect to x. So the derivative of the top is 1 into x squared plus y squared minus x. The derivative of the bottom partially with respect to x is twice x. And you divide everything by the square of the denominator, like so. Which means partial f, partial x. Okay, so this is minus 2x squared, giving us exactly y squared. Giving us exactly y squared. Okay, this x squared minus 2x squared, which is minus x squared divided by x squared plus y squared squared. Moreover, what do we do next? We do the following. So now we have partial f, partial y. So the partial derivative of f with respect to y. Okay, first we differentiate using the quotient rule. So we differentiate the top. Derivative of x with respect to y, partially it's 0. X squared plus y squared minus x. And the derivative of the bottom with respect to y partially, it's 2y because the derivative of the x squared is 0. you square of the denominator, like this. So it's minus twice xy, x squared plus y squared, squared. Hence we have dy dx. It's minus f sub x divided by f subscript y minus. And now, what is f sub x? It's the top. And that's exactly y squared minus x squared divided by x squared plus y squared, like this. And then you have x squared plus y squared squared. You divide by 2xy. So in other words, if we are dividing by f sub y, we alternatively multiply by the reciprocal of this. So this cancels out, and the negative gives us a positive, yielding y squared minus x squared divided by twice xy. And if you look at these carefully, I mean, there are a couple of things you need to realize when you look at these and think, but we have the same result as we got before. And what is the result? The result is we got before that dy dx is y squared minus x squared all over 2xy, but that is what we got before, y squared minus x squared all over 2xy. So here we used a result we call the implicit function theorem, this one here. And we used here what you call the quotient. We used the quotient rule. We used the quotient rule to find a derivative, and we certainly are done with this problem. And that is the answer. And so in view of what we had to do in the beginning, we had to find the dy dx by using implicit differentiation, and we went on to put because this kind of function we're dealing with here is called a multivariable. It's called a multivariable function. Okay, sorry, yeah, because it has two variables. Okay, so multivariable functions have several variables, two or more variables. Okay, in which case, therefore, we are done with this problem. So yeah, thanks everybody. A very good bye to you.